All right, everybody, page 11 of the Chapter 3 notes. Finally, we're at the multiplication rule. We talked about the addition rule, right? Remember, the addition rule tells us how to handle an OR statement, right? And so that's the probability of A or B. You take the probability of A plus probability of B, and then you've got to subtract that double counting A and B that we do. Okay, so this is how we handle an OR statement. We use the addition rule. The multiplication rule is for handling an AND statement. All right. Now here's the rule. The probability of A and B is the probability of A times the probability of B given that we know A took place. Okay. When we actually get to some practical examples, I think this becomes easier to see. Okay. Now, if these events happen to be independent, remember we just learned that if they're independent, that this guy becomes just the probability of event B. Remember, if they're independent, A has no impact on B, so we could just call this the probability of event B happening. All right? Probability of A times the probability of B. Many things we look at, though, are dependent, so it's probably more likely that you're going to be using this idea. This formula can be derived from this formula. If you recall how we defined this, I don't remember when, a few pages back, but this was the formula to be used for finding conditional probability. Remember, I say that I do not use this formula generally. I just try and use the concept. Remember, I would think of it as, okay, that happened. Now my sample space has shrunk down. It's something new. From that new sample space, what's the likelihood that I get B? Anyways, if you take this formula and you simply multiply this piece to the other side, multiply both sides by the probability of A, squeeze it in here, those are gone, and there you have it. That guy is equal to the probability of A times the probability of B given A, just like here. Okay, let's get some practical examples on this thing. So let's say that there are 7 colored marbles in an urn, 3 red and 4 green. You take 2 marbles out randomly without replacement and record their colors drawn in order. This is the big thing, and that's why it's bold that we've got to pay attention to, whether or not we're using replacement or not. Without replacement means you do not put the marble back after you've recorded your results. So after we select the first marble, we do not put it back. Before selecting the second. And that right there makes these two events independent of one another. Because as soon as you pull a marble from the bag, your sample space has changed. You've got less marbles in there. So the probability of pulling out another marble, whatever the color is now different than had all the marbles been in the bag. So let's just give this a shot. They say, what is the probability of drawing a red first and then a green? So I want the probability of red first and green second. Right? That's what I want to happen. The probability of getting a red first and green second. Well, for now I'm just going to, like I did with the addition rule, I'm going to keep writing out the probability rule until I get a good grasp of it. It's the probability of getting a red one first times the probability of getting a green one second, given that we know we pulled a red one out of the bag. Okay. So let's think of our marbles. Again, it says there's 7 marbles here. I've got 3 red and I've got 4 green. Okay. So first things first, if I'm going to find the probability of getting a red marble, okay, well, out of 7 marbles, 3 of them are red, so 3 out of 7 would be the chances of getting a red marble. Let's say I did that. Let's say I've got a red marble, and in other words, I'm going to consider one of these guys gone. Again, I'm not using replacement, without replacement, so it's not like I say, oh, that's red, and then put it back in the bag. I say, that's red, and I hold it outside of the bag. And then I reach back in the bag and hope for a green one. The probability of getting a green one, well, there's 1, 2, 3, 4 green ones available. Out of 1, 2, 3, 4, 5, only 6 now are left in the bag. Because again, that first one, red, was plucked out. If you multiply these out, I believe we get 2 over 7. Oops, not 2 over 2, 2 over 7. Let's try this one. What is the probability of drawing a red first and then a red second? A red and another red, again, without replacement. So I'm looking at the probability of getting a red one first, and I'm going to multiply that by the probability of getting a red one on the second go around, given that I've already plucked out a red one, because again, I'm not using replacement. So let me come back to my diagram here and put the marbles all back in the bag. The probability of getting a red marble, we said out of all 7 marbles, 3 are red. Now the probability of getting another red marble, wait a minute, let me cross one out. I'm looking for the probability of getting a red one. I did, right? Because I'm looking at the probability of getting another red one, given that I've already pulled one out. All right, well, I already took one marble out, one red one. So what's left? How many ways are there to succeed at this? There's 2 red marbles left out of 6 marbles in total. This would come out to 1 over 7. That would be the probability there of getting 2 red marbles in a row without using replacement. Okay. Now, when you use replacement, it means you don't do any of this crossing out of a marble thing here. It means that you look at the marble, you acknowledge that it's red, and then you put it back in the bag and shake up the bag. So your sample space doesn't shrink, because every time you draw a marble, there's always 7 marbles in the bag, 3 red and 4 green. When you're not using replacement, again, every time you pull a marble out, it stays out, and therefore that has an impact on the next, the probability of getting your next marble drawn. So here, it's the same question, but they're going to use with replacement. Okay, so with replacement means that after we record the marble, we put it back. Before getting the next. Okay, so here they say, again, same scenario. I've got 7 marbles, 3 red, 4 green. There's my marbles in a bag, but this time I'm using replacement. I'm replacing the marbles as I draw them out. They want to know what's the probability of getting a red marble first and then a green one. So red first, oops, and green second. All right. Same thing we did up here, but up here we were not using replacement. So when I came to find the probability of getting a green one, there was 1 less marble in the bag. I had already pulled a red one out. That's why we see only 6 marbles available here. Now in this case, we're using replacement, so I want the probability of getting a red one first. I'll still write out the rule, and then times the probability of a green second, given that I got a red one on the first try. Okay. Well, if I want the probability of getting red, again, that's 3 out of 7. Now here, remember, we're using replacement. So once I pull out this red marble, I look at it and go, oh, it's red. I then put it back in the bag and mix them up. In other words, I'm not crossing this out. There's always 7 marbles in the bag. So when it comes time to pull this guy out, and I want to know what's the probability that I'm going to get green, given that I got a red one first, it's just the probability of getting a green one, because all 7 marbles are in the bag. Oops. So out of those 7 marbles, 4 of them are green. You know, the green one doesn't care that you pulled a red one out. It's just looking at, well, there's 7 marbles here and 4 are green. So that would be that probability, which comes out to 12 over 49. Alright, let's got to race the clock to finish this page. So let's see, what's the probability of drawing red and then another red? Same question, but again, here we're using replacement. Red first and red second. Okay, I'll write out the rule again. Probability of red first times the probability of a red second, given we drew out a red first. Alright, well, looking at our bucket of marbles, the probability of getting a red is 3 out of 7. Now, again, I don't hold that red marble out. I pull out a marble, I go, oh, you're red. I put it back in the bag, so none of these are crossed out. There's still 7 marbles. So the chance of getting another red one is simply still going to be 3 out of 7. It doesn't matter that I already pulled out a red because I didn't keep it out. You know, I put it back in the bag before I grabbed this guy. Anyways, this will come out to 9/49. So with and without replacement is really something important to hold on to, because the same question has different answers depending on whether or not you're using replacement. Let's see if we could finish this example off here. It says, draw 3 cards with replacement. What is the probability that all 3 are hearts? So I want the probability of heart and heart and heart. Okay. Well, if you look at all the cards in the deck, it's an and. First of all, it's an and statement. So I'm thinking multiplication rule. I'm going to multiply. If I think of all the cards in the deck, out of 52, 13 of them are hearts. Or we've done this before where I know that, you know, the probability of getting a heart is 1 out of 4. So the probability of getting that first heart is 1 out of 4. And then I'm using replacement. So after I've drawn the card, I then put it back in the deck. In fact, let me write it this way. There's 13 hearts out of 52 cards in the deck. Okay. All right. Well, to get this next heart, I replaced the card back in the deck. So I've still got a deck that holds 52 cards, and 13 of them are still hearts. And to get this last heart, again, I'm using replacement. So every time I pull out a card and look at it, I then put it back in the deck, shuffle it. So the chances of pulling out a heart there are, again, 52 out of 13. This should multiply out to 0.01562, or 3, depending on how we round. All right, let's see if I can do this. Now it says draw 3 cards without replacement. What's the probability that they're all 3 hearts? So now we are not using replacement. So the probability of getting a heart and a heart and a heart, well, I still take the probability of getting a heart. Out of the 52 cards in the deck, 13 of them are hearts, so I have 13 out of 52 is my probability of getting that first heart. And then I am not replacing them. So in other words, that card stays out. So now there's 1 less card in the deck, and there's also 1 less heart. To get this second heart, there's only 12 available because I plucked 1 out of 51 cards. Same goes for this last one. If I want this last heart, there's only now 11 hearts available and only 50 cards left in the deck. This would come out to 0.0129. You can see it's pretty different. I'm about to run out of time. I'll be back with another video.